Let us take a general polynomial p of x of degree 2, that is a quadratic polynomial. So we have p of x equals ax square plus bx plus c. Now what happens if we equate p of x to 0? So we have p of x equals 0 or ax square plus bx plus c equals 0. And this is a quadratic equation. So what have we done here? We have just equated a quadratic polynomial to 0 and we got a quadratic equation. So a general quadratic equation in variable x is of the form ax square plus bx plus c equals 0. Now a, b and c are real numbers and a can never be equal to 0. Okay? Let me give you a couple of examples of quadratic equations. There. X squared plus 4x plus 5 equals 0. 3x squared minus 2x minus 1 equals 0. Similarly, you can create many more quadratic equations of your own. Now, a lot of times we also encounter equations which do not seem quadratic at first. But if we simplify them, then we come across quadratic equation. For example, consider the equation x minus 12 by x equals minus 4. Now, this is not looking like a quadratic equation. We cannot see any variable x that has a degree 2. So what do? We simplify it. We take x as a denominator there. Now we cross multiply there. And we take the terms on the right hand side to the left hand side there. So what do we finally get? X squared plus 4x minus 12 equals 0. And hey, this is certainly a quadratic equation, right? Similarly, some equations actually look like quadratic equations, but they are not. For example, x squared plus 2x plus 6 equals x squared plus 4. Now, if you start simplifying this equation, x squared cancels out on both the sides. And what do you get? 2x plus 2 equals 0. And hey, this is a linear equation, right? So whenever you come across a question in which you need to identify whether the equation is quadratic or not, always simplify the equation first. Only then can you tell whether the equation is quadratic or not. Here we have two equations. X squared plus 4 root x minus 8 equals 0 and 5x squared minus 9x plus 8 equals 4x squared minus 7x plus 10. And we need to state whether these are quadratic equations or not. Remember, quadratic equations are of the form ax squared plus bx plus c equals 0, where a, b and c are real numbers and a is not equal to 0. So the permissible powers of variable x are only 2 and 1. We can also include 0 because we can write the constant term c as c into x to the power 0. Okay? Now the first equation is x squared plus 4 root x minus 8 equals 0. We can also write root x as x to the power 1 by 2. So the whole equation can be rewritten as x squared plus 4 into x to the power 1 by 2 minus 8 equals 0. But hey, we had just said that the permissible powers of variable x are only 2 and 1. So where did this 1 by 2 come from? This means that this equation is not quadratic in nature. We now move to the second equation. 5x squared minus 9x plus 8 equals 4x squared minus 7x plus 10. Now this equation can be reduced further. Before giving any judgment on this equation, let us first simplify it. So we have 5x squared minus 4x squared plus 7x minus 9x plus 8 minus 10 equals 0. We have just brought the terms together on one side of the equation. And this further reduces to x squared minus 2x minus 2 equals 0. Now this is clearly of the form ax squared plus bx plus c equals 0 and is thus a quadratic equation. You see triangle ABC? It is a right triangle and right angled at B. Now we have some information about this triangle. We know that side AC, which is the hypotenuse, that measures 2 centimeters. So let's write that. And we also know that the base BC is 5 centimeter less than twice the height AB. Now we need to determine whether this situation is possible or not. We can do this by finding all sides of the triangle. So let's assume AB to be X. We write that in the figure. Now see this condition again. The base BC is 5 centimeter less than twice the height AB. So what is the length of base BC? That is 2x minus 5, right? Now since triangle ABC is a right triangle, it will satisfy Pythagoras theorem as well. And we have AC square equals AB square plus BC square. Let's now substitute the values. And we get 2 square equals x square plus 2x minus 5 square. You simplify this and the final equation that you obtain is 5x square minus 20x plus 21 equals 0. Now we need to solve this quadratic equation in order to find the value of x. So let's employ the quadratic formula. And what does the quadratic formula say? X equals minus b plus minus root b square minus 4ac by 2a. Let's substitute the values here. And we have x equals minus of minus 20 plus minus under the root minus 20 square minus 4 into 5 into 21 by 2 into 5. You simplify this further and you get x as 20 plus minus root of minus 20 by 10. Now observe the square root here. That is negative, right? And this means that the values of x are not real for this equation. And since the values of x are not real, this means that the sides of triangle ABC are also not real. So we can safely say that this situation for triangle ABC is not possible at all. Now look at this quadratic equation. X squared plus 5x minus 500 equals 0. Now we need to solve this equation by the method of factorization. So what we first need to do is, obviously, factorize this. So let's compare it with the general form of a quadratic equation. What is the general form? Ax squared plus bx plus c equals 0. Now when we compare the two, what we get is a equals 1, b equals 5 and c equals minus 500. Now the first step is to multiply a and c. So what is the product? That's 1 into minus 500 or minus 500. Now we need to list all the factor pairs of this number. So what are the factor pairs of minus 500? Don't worry, let me write them down for you. There. Now look at the value of b. Now what we need to do is, we need to choose that factor pair, the sum of whose terms will give us 5. That is the value of b. Okay? So what we are trying to do is, get two numbers whose product equals the value of AC and whose sum equals the value of b. So let's look at the factor pairs. Now look at this pair, minus 20 into 25. Now what is minus 20 plus 25? That of course is 5. And 5 is the value of b. This means that this is the required factor pair. So let's go back to the equation. X squared plus 5x minus 500 equals 0. Look at this 5. Let me write this as minus 20 plus 25. Let me now simplify this expression. So I get x squared minus 20x plus 25x minus 500 equals 0. Look at the first two terms. Let me take x common. So I get x into x minus 20. Now look at the last two terms. Let me take 25 common. So I get 25 into x minus 20. The expression with us is x into x minus 20 plus 25 into x minus 20 equals 0. So how can you write this in factor form? X plus 25 into x minus 20 equals 0. So this means that we can factorize x squared plus 5x minus 500 equals 0 as x plus 25 into x minus 20 equals 0.
Here is a sitter. This is the equation we have. x squared plus 6x plus 9 equals 0. We need to show that x equals minus 3 is a solution. Now what do? Well, it's given. Take the value of x as minus 3 and substitute. There you go. Minus 3 whole squared plus 6 into minus 3 plus 9. So 9 minus 18 plus 9, which of course has to be 0. So, and that's what our right hand side is. So what do we have? X equals minus 3 is indeed a solution of x squared plus 6x plus 9 equals 0. We do what we normally do. We take the smaller number as x and the larger number, the difference is 4. So it is x plus 4. Now to the condition. 1 by x, the reciprocal of the first number, minus 1 by x plus 4, the reciprocal of the second number, is equal to 4 by 21. A bit of manipulation, cross multiplication, and we have our quadratic equation. X squared plus 4x minus 21 equals 0. Let's split the middle term. X squared plus 7x minus 3x minus 21 equals 0. So x, as you can see, can take two values, 3 or minus 7. If x is 3, then what is x plus 4? That is 7. And if x is minus 7, then x plus 4 is minus 3. So there are two possibilities. The numbers could be 3 and 7, or the numbers could be minus 7 and minus 3.
Let us first look at the quadratic formula. So let me take a general quadratic equation. Ax squared plus bx plus c equals 0. Here a, that of course is not equal to 0. Now we will first complete the square on the left hand side of the equation. So how do we begin? We first divide the equation by a, and what we get is x squared plus b by ax plus c by a equals 0. We now need to complete the square, and we can do it like this. X plus b by 2a whole square minus b by 2a whole square plus c by a equals 0. Now look at this part of the expression. We need to simplify this. So I can write this like minus b squared by 4a square plus c by a. Let me now take the denominator as common. Let me now take this on the right hand side. So what do I get? X plus b by 2a whole square. This equals b square minus 4ac divided by 4a square. Now we need to take square roots on both the sides. There. Now if b square minus 4ac is greater than or equal to 0, then always remember you will have two values, one positive and one negative. That is why we have placed this sign here, right? Now let me take b by 2a to the right hand side. So what do I finally get? X equals minus b plus minus square root of b square minus 4ac by 2a. What does this mean? This implies that the quadratic equation with us was ax squared plus bx plus c equals 0, and its roots are there. Minus b plus square root of b square minus 4ac by 2a and minus b minus square root of b square minus 4ac by 2a. Here b square minus 4ac is greater than or equal to 0, right? But why is it greater or equal to 0? What if the value was negative? Can you tell me the answer? If the value was negative, then this means that the equation will not have any real roots. So b square minus 4ac, that will always be greater than or equal to 0. So this is nothing but the quadratic formula. Extremely helpful in a lot of situations. Suppose we have two squares of different sizes. Can you see them? Good. Now we don't know their dimensions. However, it is given to us that the difference between their perimeters is 32 meters. Also, the sum of the areas of these squares is 482 meters square. Now, how can we represent this situation mathematically? For this, we will need the help of quadratic equations. We don't know the dimensions of the squares. So let us take the length of the smaller square to be x there. So the perimeter of this square will be 4x. Now let's look at the first condition. The difference between the perimeters of the two squares is 32 meters. So the perimeter of the larger square would be 32 meters more than the perimeter of the smaller square. So the perimeter of the bigger square will be 4x plus 32. And what will be its length? That's right. It will be 4x plus 32 divided by 4, or x plus 8. Let us write that down. Now let's look at the second condition. The sum of the areas of the two squares is given to us as 482 meters square. Now the length of each side of the smaller square is x. So its area will be x square. And the length of each side of the bigger square is x plus 8. And so its area would be x plus 8 whole square. And the sum of these two areas is given to us as 482 meters square. So what do we have? X square plus x plus 8 whole square equals 482. Let's open up the brackets. And we have x square plus 16x plus 64 equals 482. And we can further simplify this as
2x square plus 16x minus 418 equals 0, or x square plus 8x minus 209 equals 0.
And this is our required quadratic equation. In fact, we come across many situations in real life which can be expressed mathematically using quadratic equations. And how do we master this technique? Simple. Lots and lots of practice.